On this RAM 1500 with the 3.6 Pentastar, P0522 is an engine oil pressure sensor circuit low code. In plain terms, the PCM may be seeing the oil pressure sensor signal pulled lower than expected. The driver may only notice the MIL, and the fault area can be the sensor circuit, the 5-volt supply, the sensor ground side, connector integrity, or the sensor itself. Before getting deep into pinpoint tests, start with the basic system checks and follow a structured diagnostic approach. For this circuit, the PCM provides a 5-volt supply to the engine oil pressure sensor and also provides the sensor return. Depending on the PCM hardware, the signal circuit can use a 5.0 volts pull-up or a 0.0 volts pull-down, so do not assume every vehicle behaves the same internally. The monitor runs with ignition on and battery voltage above 10.4 volts. The code sets when the EOP sensor signal voltage at the PCM is below 0.290.1 volt depending on calibration for approximately 1 second. When it sets, the MIL will illuminate. First, use the scan tool to read codes in all electronic control units and record the codes and environmental data. Save the vehicle scan report and the related recorded data for reference. Then erase all codes, turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on, and reproduce the operating conditions that set P0522. Read codes again. If P0522 returns, keep going with this circuit diagnosis. If it does not return, treat it like an intermittent fault. Inspect for loose connections, terminal fit issues, harness movement, and anything that could make the signal drop only under certain conditions. Next, look back at the recorded codes. If there are any 5-volt reference codes present, diagnose those first. A shared 5-volt problem can pull multiple sensors into trouble and send you down the wrong path if you chase the oil pressure sensor alone. If there are no 5-volt reference codes, move on to the EOP sensor connector and circuit checks. With the ignition off, check the EOP sensor connector before you unplug it. Make sure it is fully seated and locked. Then disconnect it and inspect for pushed-out terminals, damaged terminals, or spread terminals. If you find a connector or terminal issue, repair that condition or properly connect and lock the EOP sensor connector. Then verify the repair and confirm the code stays gone. If the connector and terminals look good, leave the EOP sensor connector disconnected and measure the voltage on the 5-volt supply circuit at that connector. The expected result is between 4.9 and 5.1 volts. If it is in range, continue to the signal circuit tests. If it is not in range, repair the 5-volt supply circuit for an open or a short to ground. Then verify the repair and confirm the code stays gone. Now isolate the EOP sensor pressure signal circuit. The ignition must be off when checking continuity to ground or checking continuity between circuits. Disconnect the ECU and every component connector that contains the circuit being tested, and use the wiring layout to follow the circuit path. If a PCM connector terminal needs to be accessed, do not probe the PCM harness connector directly. Use the GPEC Diagnostic 10436 adapter so the PCM terminals are not damaged. First, check the EOP sensor signal circuit for a short to ground. There should be no continuity between the circuit and ground. If continuity is present, repair the short to ground, using inline connectors as possible isolation points. Then verify the repair and confirm the code stays gone. If the signal circuit is not shorted to ground, check for a short between the EOP sensor signal circuit and the sensor ground circuit. Again, there should be no continuity between those circuits. If continuity is present, repair the short between the circuits, then verify the repair and confirm the code stays gone. If those checks pass, check the EOP sensor signal circuit for an open or high resistance. Before measuring the circuit, measure the resistance of the DVOM leads so you know what the leads are adding. Measure the circuit from the component connector to the GPEC adapter. The GPEC Diagnostic adapter can add up to 1.5 ohms of resistance to the circuit, and the expected circuit resistance is below 3.0 ohms. If resistance is not below 3.0 ohms, repair the signal circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. If the wiring checks pass, the next move is to prove whether the PCM can recognize a high signal on that circuit. For this test, the ECU harness connectors must be connected to the ECU. Disconnect the sensor harness connector, keep the ignition off, and connect a fuse jumper between the EOP sensor signal circuit and the 5-volt supply circuit at the EOP sensor connector. Turn the ignition on and read codes with the scan tool. If the scan tool shows the expected sensor signal circuit high code with the jumper in place, the PCM saw the force change on the signal circuit. At that point, the diagnostic path calls the EOP sensor faulty. Replace the sensor, then verify the repair and confirm the code stays gone. If the PCM does not show the expected high signal code with the jumper installed, continue into the related PCM and harness connection checks. For the final connection check, perform any applicable service bulletins, then disconnect the PCM connectors, any related inline connectors and the related component connectors. Inspect the harness and component connectors, male and female terminals, locks, weather seals, and terminal tension. Look for corrosion, water intrusion, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and poor connector seating. Repair any condition you find. Reconnect the PCM connectors, inline connectors, and related component connectors. Make sure every connector is fully seated and locked. Erase the codes, then test drive or operate the vehicle under the same monitored and set conditions. Read codes again. If P0522 returns after these checks, the diagnostic path calls for replacing and programming the PCM, followed by repair verification. If the code does not return, the wiring or poor connection problem has been repaired. The takeaway is simple. Prove the code is active, rule out shared 5-volt problems, inspect the connector, test the supply and signal circuits, then use the forced signal test to separate a sensor fault from a PCM or connection issue. For more diagnostic training, visit stepdiagnostics.com.